Okay, we're live on YouTube now. Yes, YouTube is live. Okay. Yeah, okay, we're gonna get started now. Yeah, so this is our intro to video game hacking workshop. Um, it's kind of a passion of mine. It was one of my major attractions to programming, I guess, at a younger age. I did a lot of hacking in CS:GO. It kind of, it sounds a little bit niche, but it isn't as niche as one would think because it's really related to reverse engineering. So that goes insofar as analyzing viruses, penetration testing, so forth, so forth. Um, Cracking software, but I guess that's not really a skill that is employable. Um, yeah, so today we're going to cover a few things. We're going to cover the general video game hacking techniques, and the theory behind it, the thought process you should take on anytime you want to look at a certain game, and have some sort of exploit you want to create. Um, we're gonna cover the difference in between modifying binaries, so modifying software, versus memory editing, so editing the RAM at runtime, in order to perform certain functions that were not intended for you. Um, and we're going to cover internal versus external cheats. So those are two different types of memory editing cheats. Um, and then using this knowledge, we're going to transition into some hands-on hacking. Um, and this is going to be using Counter-Strike Global Offensive. So some of the things are aimbot, ESP, so visuals, Bhop, which is it's kind of specific to CS:GO, but you guys will get it when I show you. Um, Removing recoil and triggerbot. So yeah, so first thing we want to do is we want to get a bit of a recap on when we have an operating system such as Windows, what the responsibilities of that operating system are, and how this can aid us, how we can abuse this operating system, so to speak, in an advantageous fashion for cheating in video games. Uh, so first, the operating system is responsible for managing the computer's resources, being the hardware, the RAM, the CPU, et cetera, bringing that all together. Um, it's responsible for providing a user interface, sure. And then the most important piece is that it's responsible for executing and managing software in order to provide services for the software. So this includes a number of APIs, and whatnot that interface with certain parts of Windows, i.e., certain APIs you can use to communicate with other programs, and access their memory and whatnot that we will kind of lead into in a moment. So when we think about game hacking, as I already mentioned, there's two different methods insofar as game hacking goes. The first is modifying binaries, and this is potentially difficult depending on which language the game was made in. So your standard, C++, C languages, they're going to compile down to nitty gritty assembly machine language, and modifying this is pretty difficult, if it's not only little segments. We can try to decompile these programs, and there are some softwares out there that get some form of C code that could have potentially created the machine code you're looking at in an executable file, but they're just not that great. So generally, our approach when it comes to games that are created in C, C++, is we're going to try and edit the memory at runtime. Or sometimes people will make exploits, like they'll take the DirectX, so the most common game engine used in Windows, basically. They'll take a DirectX library and they'll swap that out for a cracked DirectX library that has been modified to perform some sort of function or to load some external library that you want loaded at runtime, and that will be their way in. So they only change a little bit to that, but you can't really get directly at the code that your software came from in general when it comes to C and C++. And then the second method is runtime memory editing. And that's when the cheat is going to be modifying the memory of a target process while it's executing. It's going to go into the RAM, it's going to go look at the bytes and do certain functions at runtime that are going to get you to a certain desired result. We're just going to look a little more into depth about those two approaches. So modifying binaries can be advantageous when you have software created in languages that do not use C, C++. So languages that will compile into bytecode, which are interpreted by an interpreter at runtime. So these would be languages such as your Javas of the world, your C Sharps of the world, compiled Python, and you can actually get software that really easily decompiles this, including like variable names and stuff. So you can get basically the original source code back from a C Sharp or a Java program, and you can modify that, and then you can compile it again, and you can really easily exploit or modify the software. So when it comes to Unity, a lot of games are made with Unity, especially if you look on the Steam store. The majority of cheap early access small developer games are made in Unity, and that's C Sharp. Granted, there are some ways to get around this as a developer. Their efficacy is questionable, but you can obfuscate software, so it's called. And this is there's a few techniques as far as obfuscation. One of them is adding junk code. So when you have your code, you have line 1, line 2, and line 3, you can add 5 random lines that look like they mean something but mean nothing in between line 1 and 2, same between line 2 and 3. And this can make it very difficult to reverse engineer sometimes, because you end up following a dead trail. The other thing is to confuse data. So you could, there's so many sequences. If you have a string hello, there's a billion different sequences you can take in order to create the string hello. You can make it as convoluted as humanly possible to make a single string. And so same goes for integers. I mean, you can add and subtract, multiply to get to some desired integer. And this can be done to make software look super confusing, even though it might not be that. And this is really useful for preventing hackers. And not even just in the game hacking space, it's very useful in the space of preventing cracking of software, which is also done through modifying binaries. Yeah, and so this whole process occurs at the software level, as it's probably pretty obvious. This isn't our focus today. We're going to be exploring memory editing techniques. In particular, the main example we're going to be looking at is an internal cheat, and I'll talk more on that in a sec. Yeah, so memory editing at runtime describes interfacing with an application, a target application, through platform-specific binaries. So these would be your Windows API. Like Windows has, as it says here, yeah. Windows has a memory API.h header, and this includes read process memory, write process memory, open process, which opens a handle to another process, so you're allowed to write to memory, basically so that you can utilize some functions to look at, a certain address and fetch that data that's at that address, or write to that data that's at that address. Yes. And yeah, so this exists. It has counterparts in Mac OS. Actually, I can't tell you about Mac, but I'm sure it does. I know Unix for sure. There's counterparts. I'm just not familiar with them. And yeah, that basically covers it. And this occurs at the memory level and not the software level. Again, two distinctions, because if you're doing something at the software level, every time you boot that game, it's going to do the exact same thing. Whereas at the memory level, you're going to have to be doing something, modifying the memory at runtime every single time if you want to get the same result. If you close the game after you've done something, it's not going to stay there. And just a bit of a recap. I don't know how familiar everyone is with, basic machine architecture, C++, how memory is addressed. But basically memory, you can just think of it as existing in, chunks of bytes that are addressed from low to high. So if we wanted to see, what bytes exist, they're represented here as hexadecimal. What bytes exist at this memory address, 401000. You can see, 55 is here, 8B is here, so that'll be the next byte over. The next byte will be EC. And so these are what we target. And these bytes in memory obviously can represent target values, so to speak, that we want to modify somehow. So, the health could exist at memory address 40120 here, for instance, and that would be an integer, so a 4-byte variable. And we could either read or update this 4-byte variable at this address in order to modify the health of the user. Or it gets way more complex than that, but that's just a basic example. So external versus internal. External, as I mentioned, it uses the read process memory, write process memory, Windows wrappers in order to modify games memory. It requires process access rights and an open handle to the process. That's important, especially in terms of anti-cheat detection, because when you've got an open handle saying that you're allowed to read and write memory from the process, it's really obvious that your process is modifying that game in some way. And same with the process access rights. It has to query the OS for this, and there's easy ways for game developers to watch for you doing this, to just block it. Even you don't need to be punished for it, so to speak. They can just totally block read process, write process memory. And this sort of cheat will come in a self-contained executable file, runs on its own. You can have a GUI for this or whatever. It's totally separate address space from the from your game that you're trying to target. And internal cheats require an injection of foreign code into a target process via a DLL injector. If you've done any sort of game hacking, this will be really obvious, even if you just downloaded something from online. DLL injectors are the most common, I want to say, way for cheats to be deployed. There's a number of DLL injection techniques, and this is faster to do, like an internal cheat, because you have direct access to the memory. You don't have any sort of API overhead, because it takes time to query the Windows API, obviously, and this slowdown can get ridiculous. So if you're running in the same address space, your code is running inside of the code of the game itself. It can directly access this memory as if it's part of the game, and it will go a lot quicker than having to query Windows all the time and wait for Windows to give you a result. This comes in the form of a dynamic link library, DLL. It's basically it's a module. It can't run on its own. It's dependent on the existence of another parent process. And this is deployed. This foreign code is deployed into our target process using some sort of DLL injector. So the pros and cons of external cheats versus, and then internal cheats will come next. External cheats benefits: much lower barrier to entry, not detected by some anti-cheats, i.e. Valve anti-cheat for CSGO that we're going to look at doesn't detect this, even though it's really simple. It's really easy to make a cheat for the game. It's a big game with competitive play, but anybody can go and make a simple external cheat, do an aimbot, do an ESP, anything. They can get a serious competitive advantage. So that's kind of funny. And it's got a smaller code burden generally. So if you're doing a small patch of bytes, like just some little things you want to do in your cheat, don't require frequent update, not much code, this is the best. The cons are that it doesn't run in the same address space, as we mentioned. This can be, there's a number of reasons why this isn't as good. It can be slow. That's part of why it's not as good. as well, you can't perform hooks. So in order to constantly modify the memory at runtime, you have to do some sort of loop, and it's arbitrarily modifying the value, but it's not modifying it, so to speak, based on the game, right? Like if you have an update function that renders your content on the screen every 60 milliseconds, let's say, and every 60 milliseconds the game updates it. And you need to, before this update, you need to modify some sort of memory. You're going to have to arbitrarily just loop, and keep setting this memory independent of when the game is updating. And it's going to be really inefficient. As to, if you're an internal cheat, you could hook it, so to speak, so that every time right before the game updates, you do your thing you want to do, and it's perfectly efficient, so to speak. External cheats have low potential. You can't perform hooks, just like I said. This includes V-table hooking and all sorts of other techniques. It's just not good. I mean, this is where I started. This is where I did most of my cheating, but it's just not good. And it's easy to detect. Valve anti-cheat is an exception, but every competent anti-cheat of the world, whether it be BattleEye, Easy Anti-Cheat, if you're familiar with gaming at all, you'll know these terms. They'll detect it, and they won't even detect it. They don't need to, because it's that easy to block. They just block it outright. Internal cheats. Internal cheats have exceptional performance, high potential, capable of hooking. I just explained that. They can be very difficult to detect if they're done smartly, because there's a crap load of different techniques for which we can deploy these cheats, a number of different DLL injection techniques. And it runs in the same address space. So it's easy to, if you want to access whatever at a certain memory location, it's as simple as just dereferencing that pointer, and you've got access to it as if it's part of your program. Yeah, so there's actually an example here. If you knew that your player, like an object that represented your player, was located at this memory address, you could simply take this memory address, dereference the pointer, and add the offset from the player object to the pointer that represents your health. Because if it was an object like a class in C, from that player class, you would have an offset of however many bytes. However many bytes farther from the start of the player object, the health, it will always be at the same spot. So you would go a little farther into the memory from the player, and you dereference this, and you could set the health that easy. It's as if you're running, natively. Yeah, okay. And so DLL injection is, like I mentioned, is the most common technique of deploying these cheats. It's the premise of every internal cheat. It involves injecting an external DLL into the memory of a target process. The code will run in the same address space as the target. It allows a program's behavior, so the target program, to be modified in a way that wasn't intended by the original developer of the program. And this is what we want. Yeah, if anyone's done any cheating before, Extreme Injector I use as my example. It's a popular popular DLL injector that's on a ton of hacking forums. But obviously stuff like this will be detected. So the one technique I'm going to kind of explain, because it's super simple and it's worth it for injecting DLLs. It's also very easy to detect, as would be assumed. It's detectable via monitoring when threads are created in your foreign process. They can easily use the Windows API to see what threads are created in that process. And if it's a suspicious one, they'll start looking at your program, send it for evaluation, look it up in a database of known cheats, so forth, and they'll identify whether it's malicious. It's not recommended in games with any competent anti-cheat. It used to work in CSGO, I know, for the longest time. I haven't played the game in ages, so I don't really know right now. Today I'm just going to be using Extreme Injector and just disabling the anti-cheat just for the sake of demonstration. If you wanted to do anything in CSGO as far as anti-cheat goes, you'd have to just do manual mapping. I might have mentioned that already. If not, I'm going to mention it in a sec. So the process of load library and create remote thread goes as such. So your malware will attach to the process, and this is using our methodology of external cheats. It's the same sort of idea. Attaching is opening a handle. So it's calling a Windows API function to do that. Allocating memory for the DLL path. So it's literally just using write process memory, as I mentioned, to set in there. You can see the space here. It's using write process memory to set a bunch of bytes. And these bytes are going to be the code you want to inject into your process, into the target process. And then it's going to go and find the load library function. It's a Windows function that's built into every program. And it's going to use this function, and it's going to call it and tell it to load the library at the address of the code we just injected. So it's essentially going to tell us to load the DLL we just injected in layman's terms. And then when it's loaded this code, we're going to have to call this code with create remote thread. And what this does is it's a Windows API function to create a thread on a foreign process at a certain memory location. So it's going to create a remote thread based off of this memory location, starting there at the DLL main, so the entry point of the DLL. And from there, you're going to have a new thread running in the target process in the same address space, and Bob's your uncle. You can do whatever you want in there. And this is the entire code. You can find this on Wikipedia to load library. I can quickly go over it. So you get a handle. You take the DLL and you allocate memory here for your DLL code. You write the DLL code to the memory. You find the address of load library here, and then you create the remote thread. And then there's just stuff waiting for it to be done, closing handles, freeing memory. So it's really simple. Like the brunt of the code was really above this wait for single object. This is all redundant. Like it's not like, yeah, you need it for it to be functional, but whatever. How are we doing for time now? Just want to make sure we have enough time to. Yeah, okay, we're doing good for time. Yeah, just bear with me a few more minutes, and then we'll be going into actually modifying the game. Yeah, manual mapping is loading raw binary data into the target process. It maps the portable executable sections to the target process on its own, and injects a loader shellcode. So it injects some foreign code that's going to be able to load our DLL. And this is all fancy stuff. Basically, it just does what load library does, but it avoids using the Windows function load library, and it does it itself. And we've basically written our own load library function in order to circumvent easy detection through load library, because anyone can hook load library and look for calls to load library and see if they're suspicious. The pros are it hides from anti-cheat using blah, blah, blah. And the cons are that it's more difficult, it's more prone to errors because it's hard to implement well, and it has a different implementation on 32 and 64-bit systems versus load library is pretty congruent. Offsets, addresses, and signatures, very important concept when it comes to game hacking. It describes the relative location and memory of specific pointers and objects. So when we create a program, it's going to assign certain addresses for our modules. So there are certain DLLs that are part of the program or just executable file is going to get given an address space, and it's going to get given some specific memory address. Now, the thing that we find is certain objects that are part of this program in the stack, they're going to get the exact same offset from the start of the module every time. So that's why it's called an offset. So for instance, this would be an offset, right? The start of client DLL plus this amount of memory. And well, module addresses change at runtime. The offsets are fixed, like I said. So an example of this would be if we know that there's a pointer to the player's health that exists this offset here away from the start of client DLL, we could address it by just dereferencing that pointer using the following code. So internal, you see it's pretty simple. You just find the address, the start of the module, and then you go and you add your offset to that address, and this is going to be your pointer to the player's health. And when you dereference this, that's going to give the health of the player. That simple. Versus if you're using external, you'll have to go through the Windows API, and this get module handle is part of the Windows API. It's a function, no more is needed. But this get module, I just made this up. This isn't an actual function. You'll have to create some big ass function yourself that does this function, finds the start of a module. So it's a lot more work in some degrees, and then you'll have to use read process memory to read the health. Pattern scanning describes a technique or signature scanning, they're analogous, to locate an object in memory dynamically. So when there's game updates or software updates, the address in memory is actually going to change. Not just the dynamically allocated part, but the fixed part, right? Our offsets will change because when new code's added in between, the start of the module and where our offset is, it's going to get bigger, smaller if they remove code, whatever, right? The way we can get around this is we can look for a pattern of code around the piece of memory that we like, and by searching for this sequence of bytes, we can, in effect, locate dynamically a certain offset every single time, even if there's software updates, because the pattern around it stays the same, even if the distance from the start of the module doesn't. And these can be denoted in a number of ways, using just string literal sequences of bytes and a mask. Basically, you say, okay, so we want x x x x, and then 2 wildcards, and then XX. So this means that in all the X's, these bytes need to match. So you want this byte, this byte, this byte, this byte, and then whatever byte, because it's a wildcard, whatever byte, and then this byte. And so that's how a pattern would be represented. It's easy. You just loop through the memory and look for a pattern of bytes. Pretty self-explanatory. I might not have finished this slide, but I can talk about it. So our useful reverse engineering technologies are cheat engine is a very useful one. It's useful for just simple read and write of memory. It can inject DLLs, so forth. IDA Pro is huge. Not even just in the realm of game hacking, but any sort of reverse engineering, IDA Pro, that's your go-to. If you take anything out of this lecture, it's learn a bit of IDA Pro. It's really useful. And Ollie Debug is another one. It's a debugger you can attach to a process at runtime to view the memory, amongst other things. Yeah, I might go through that a little bit later in this, depending on how much time we have. But I just want to get everyone, kind of versed in the terms, and then we're just going to jump straight into some hacking. There's a little bit of pieces we might not cover. Like we might go from point A to point C in a few times. You might not understand exactly how certain numbers were gotten, but you're pretty damn close at that point to making it yourself. Shit. So here we are. Yeah, let's start coding. So we'll be creating a cheat for CSGO, Counter-Strike Global Offensive. We'll create, I said first we'll create an external cheat, but I think we're just going to start with internal. And then we'll look at my external cheat that I created a while back, and because I think the internal is more useful. It's more pure C++ and less Windows API. Yeah, so let's see if my game works here. Yeah, so I have CSGO open here, and oh, my cheat's kind of loaded already. So yeah, let's start coding. Yeah, so to start, this is just a basic DLL file. You know what? I'm just going to create the code right now because we can. So in order to start here, we're going to go and we're going to make a new project in Visual Studio. Doesn't need to be Visual Studio. It can be Visual Studio Code. It can be Visual Studio 5 years older than mine. Whatever. Any IDE works. Eclipse. New projects. And let's call it DSC internal demo. And like I said, I'm going to be using Extreme Injector to inject our cheat. Okay. And we need to create an entry point to our file. So we're going to call this DLL main. And entry points to DLLs follow the same format every time. It enters. Oh, and we need to include windows.h. Yeah, the same format every time. This function signature, these arguments, and the reason for calling this entry point comes with it every time. So we have a switch statement that goes through all the reasons this could have been called. So basically, when the DLL gets started, gets injected, this is what's going to be called here. So this is where we've entered. What are we going to do? We want to modify certain things within the game. I'm going to start by showing you guys that you don't actually need to reverse everything, engineer everything with this game. There are dumpers that have signatures predefined for certain offsets we want, and fetch them for us. So you can use these offsets to get certain parts of the game in memory quite easily. You can also learn how to get these offsets manually. I just don't think we have enough time to look at that. I might look at manually getting a few, like the health and stuff. But again, just we'll see how much time we have. For now, just assume that this is what they are and that they came out of the ether, and that's what we'll be using. So to start, I think we're going to make a Bhop first because it's super simple. Bhop is basically, in CSGO, there's a mechanic you can abuse where when you're jumping in the air, if you move in a certain way, basically like holding your key to the side you're moving and moving your mouse there at the same time and then going back and forth every time you jump, you can move faster than you could walking because of the mechanics with when you press a key in the air, it causes you to move in that direction a bit. And so if you're never on the ground and you keep jumping repetitively, every time you hit the ground, that same second you jump, it can abuse it. So the purpose of the script is simply to check if we're on the ground while we're holding on the spacebar, and if we're on the ground, we jump. And then when we land on the ground again, we jump, and we jump, and we jump. And that's all we need to create a Bhop script. So this would, we need an entry point to start with. Like we have this entry point here, but this is going to be running on the same thread as the process is. So we need to create another thread that's going to do all of our cheat related logic. Otherwise, if we're running it all in here, it's going to hang, and that's not good. So we're going to create another function, main thread, sure. And this is where we're going to perform all of our cheat related logic. And we need to create this thread as so. This is just Windows API. You can obviously look at the documentation in order to how to do this. All of these parameters are just null, besides what function we're creating a thread on. And now we've created a thread. In this thread, what we're going to do is first we need to look for the player object. Basically, the way that it exists is that I'm going to open Paint quickly just so you guys can see a little better. If this is our player object in memory, player, there's certain attributes that we need within the player object. The one we need is flags, which is some offset between the start of the player and to the flags thing. And flag says whether we're on the ground. Someone's reverse engineered this. You could do it too if you looked hard enough. But with games that people are already cheating on, you can find offsets already. So flag says whether we're on the ground or not, and this is the important thing. And then there's also somewhere in memory. There's so here I'm going to zoom out a bit. So this is our player object somewhere in memory. And also somewhere in memory, we're going to have this nice little function we can call called force jump. This guy, oh, that's horrible. I don't know what happened to my pen brush here. Anyways, so force jump, and if we set the value of that to 5, again, something someone else has reverse engineered, if we set the value of that to 5, it's going to make us jump. If we set it to 4, it resets it. So we need to set that to 5 for a second and then set it to 4 afterwards, and that's going to cause us to jump. So anytime that the flags are telling us that we're in the air, we're going to want to tell the game to jump. Or sorry, in the air. It says that we're on the ground. And this is only going to happen while our spacebar key is down. So the start of the script is going to be to check whether spacebar key is down. This is a Windows API function. Get async key state. And the highest bit on this is going to be set to high when we're holding down the spacebar. So VK space. And we shift this 16 bits over. So the highest bit is in the first position. And then we check if that's true. And that's just some C++. And then once we know that space is down, and sorry, this is going to run in a loop because we're going to keep checking this in a loop. And anytime that this condition is satiated, we're going to start running our cheat. We're going to start repetitively jumping when we hit the ground. So now our next thing is to find where is this player object in memory. Well, someone's found an offset for this. So this is the start of client.dll, DLL, and someone's found an offset for this that shows us how far in the memory pointer to player is. So there's some pointer here that points to the start of player. So and this offset exists at local player. So this is the pointer to the local player and to the local player object. And so if we want to go and find the address of the local player object, we're going to go and we're going to have to dereference this pointer. So we'll say this is a type of uint pointer. So just a pointer. And this is the pointer to the start of the address of the player object. And this is p local player. Again, it's named accordingly. And how are we going to find this? Well, we're going to find this by getting get module base or get module handle. I mean, ANSI, because my compiler is in ANSI. The A depends if you're doing Unicode or ANSI. And this is of the client.dll module. And from this module, we know that there's some offset, and this is in my offsets here in the Haze Dumper signatures namespace. And there's some offset. I gotta include my offsets. Cannot open. Oh, sorry. Offsets is in my other project. Yeah, so we'll just copy the file for offsets into our project. Again, this is provided by the dumper, easy to find online. So Haze Dumper. Not quite sure what it's being like this. I think it's just not updating I checking on my ID. Anyways, range. So create a new file, header, offsets, and that's the content. Here, haste number signatures, dword local player. So this is going to be the address here. These two things combined are going to be our address of the pointer to the local player. So this is going to be the address of here. This was the pointer to the local player that points to the start of this guy. I know they're a little bit close together, but you kind of get the idea, I think. So we're going to get the address of this. Well, we want to dereference this guy in order to get this address, which is in effect the address of the start of the player object. So in order to get the address of the start of the player object, we have to dereference this value, meaning get the value that exists at this pointer address. To do this, we use the star operator. C's not going to let us dereference it without typecasting it. So we just cast this to a pointer because that's what it is. It's a pointer to the pointer that is the start of the local player object. Okay, and in order to check now, so we found the start of the local player object. Now we want to go and we want to look at the flags. So this is some offset down from the start of the local player object. The flags exist. And so we need to find this address of the flags. So this address plus some value, and then dereference that to get flags. So this is going to be an integer, because that's what the flags are in any Valve games. And the other thing to note, sorry, this is a tangent, but for a lot of games like CS:GO, the game engine is out there. Like the source engine that they use to make the game exists. So that's how a lot of this is reverse engineered. People have just looked at the code that Valve has on GitHub, and that's how they know. So it's not totally random. Anyways, so flags is when we dereference another pointer. This time it's a pointer to an integer, not a pointer to a pointer. And this is going to exist at the local player address, or local player pointer. Excuse the phone ringing. Plus haze dumper, netvars it's in, and this is going to be flags. So flags is a part of any entity, local player or enemy, and this will dereference it, get the flags. Now we need to check if we're on the ground or in the air or whatnot. I have happened to look into the source engine and source code actually, and this is where I got this information from. And we know that if we know that our flags are represented like this. And so these are our conditions we have for our flags. So we want to check the on ground flag. And this is just a bit mask for the on ground flag. So basically it's on ground if the first bit is equal to is high, equal to 1. So we'll check flags and bitwise and operator because we need to match this bit mask. And then we want the on ground flag. I'm just going to copy and paste it here. Flag on ground. And this here to check if we're on the ground. So I'm going to have this guy just tell me right now that we're on the ground here. And so when we're on the ground, we want it to jump in theory. But I'm going to just run it so that you guys can see. Actually, you guys can't see both my screens, so there's no point to showing the console output. I'm just going to go straight to the cheat. So yeah, we want to make it jump right now. In order to jump, we want to, I'm just going to reference my original code to make sure I don't make a mistake. Yeah, so in order to jump, we want to find this integer in memory called force jump that I mentioned already. So it's this guy, force jump. And we set this to 5 to jump and 4 to not jump. And so I'm just going to copy and paste it. And it's again, it's an offset from our client module. We dereference, or we're not dereferencing it. We're actually just getting the pointer to it. This way we can modify it instead of taking a copy to it. Yeah, so we're just getting the pointer to force jump. And it's at this memory address that's this offset away from the client, start of the client DLL. So we have our pointer to force jump. We know when we're on the ground when we're holding the spacebar at the same time. So our next step is literally just making it jump in this condition. So we're going to do this by setting p force jump, and we have to dereference it. Do 5 first, like I said, to jump, and we're going to sleep. We're going to wait a little bit. This is in milliseconds, so we're going to wait for 10 milliseconds, and then force jump needs to be reset to 4, otherwise it doesn't work. This has to do with the value of the last bit. For some reason, the third bit over is always high, so that's why it's like 5 and 4. This is actually equivalent to binary 101 and binary 101 and binary 100. You can see the difference in this is that the last bit goes high and low. And then we're just going to sleep afterwards just for good measure. So that we don't jump multiple times in a row. And it just gives it some time to respond to our commands. And then when this thread is complete, we should clean it up nicely, because otherwise we're going to keep crashing our game, and it's a pain to relaunch the game, re-inject, so forth. Instead, if we're just able to clean it up nicely, that's a lot better. So we do this by calling free library and exit thread, and we need the handle to this module that's been created in the DLL main, and this is the h instance here. So we want to store this globally in h instance equal, and then we set it in here when our DLL attaches. So h inst equals. I can provide the code at the end. I actually have it on GitHub. We might not get to all of it, but I have the entire thing on GitHub for the aimbot, the ESP, and that's I'll send that at the end. So we want to set the h instance here. Sorry, h inst equals h inst DLL. I mean, and now we can free the library by referencing this h inst, and that's good. That's all we need. I think we might just need null in here. Yeah, or 0. Sorry, we need the exit code. But any program in C exits, you need an exit code 0 or 1. And we're going to make it exit this loop when we press down a certain key. So I'm going to make it just anytime we press down the insert key. Every loop iteration will check the insert key as well. And when we press down VK insert, it's gonna break from this loop, and so it'll get out of it here, and it'll free the library exit thread. And the other reason we need to do this is because if we don't free everything, if we don't free this code, CS:GO is going to be still using this DLL when we're done with it, and so it's going to be open in the process, and we won't be able to modify the DLL if we want to make changes to our code if it's still loaded in CSGO. So we need to unload it so we're able to change it, re-inject it. It's again, that's big for the development side of things and debugging. Yeah, so I think we should be good here. Unless I did something really stupid, this should run and it should do some b-hopping for us. So I'm gonna compile this first. Oh, sorry, I haven't told Visual Studio that we're going to be compiling as a DLL. So here, we're application dynamic link library, and boom, we're compiled. And so I'm going to get Extreme Injector now if my antivirus hasn't taken out of my machine yet. Okay, yeah, I have Extreme Injector. And we're going to run this on CSGO. So it's already found the process because I had it configured already. Anyways, and I'm going to add my DLL. The DSC internal demo, that's what I compile it to. Boom, let's inject that. It's injected. CSGO hasn't crashed. It's just out of the game right now, so we're just going to have to wait a second to get into a new game. And with any luck, okay. Did I crash it? Oh, that's not good. Oh, I think I might have. Let's see what I did here. So compared to my old code, I dereference it, no problem. I check the flags. I get force jump. I do this. I don't immediately see it. It looks the exact same to me, to be honest. It could have been something stupid. I'm just gonna copy this, to be honest. I think it's identical. Yeah, this code is identical. I'm like 98% sure, but I think it just was just because we injected it while we weren't in game yet. You have to do a little bit more error checking probably in order to prevent that, because I tried to call force jump before the match even started. So what happened was the game wasn't loaded. I wasn't allowed to move yet, but because I pressed the spacebar and I was on the ground, what happened was it told CSGO to jump, and CSGO was like, fuck no, we're not doing that. That's not allowed. And they've got some error checking, like in CSGO. Like, for example, when you look in CSGO, you can either look on the X axis, like up and down, the Y axis, side to side, but you can't look on the Z axis, which is the equivalent to tilt, like rotating this way. And so if you set an angle on the Z axis that's not 0, like where you rotate this way, it's gonna ban you from the game. That's one of the hard restrictions that they have that developers need to be really careful of, because if you accidentally get your offset wrong for your view angles and then you set the Z axis, you could be SOL. Okay, here we go. Yeah, so I'm just going to take it slowly this time, and I'll inject the cheat again off screen when I'm into this game. And I think we're going to have time actually to show you guys how to make an ESP, a glow ESP that shows people through walls. That would be nice. Aimbot's really complicated. Like, there's a lot of matrix algebra. that makes it very tough. Like I was looking at my old code that I wrote when I was like in whatever, like 10th grade, and I was like, holy crap, like I don't even recognize it right now, even though I've done these courses. Okay, so yeah, we're allowed to jump now, and I click injects, injection completed, and I jump and it crashes on me. Oh, that's not nice. It might have been when I created my thread that I did something dumb. Thread is good. It might be injecting both of the DLLs. That could be something that I'm overseeing because I have two DLLs here, my old DLL, and if both the cheats are running, I think that's exactly what I did. So yeah, third time's a charm. Launch CS:GO again. Sorry guys for the technical difficulties. This thing is a lot of trial and error. That's something I've definitely learned over the years. Whenever you think you've figured it out, you haven't. And it's a real pain to debug because the game crashes all the time. Yeah, just loading in the background there. One last look at this. So I'm just gonna make this look exactly like my again, I think that this code is fine, but I don't want to dilly-dally around for too long. It looks the exact same to me, so DLL process. Okay. If this doesn't work, somebody is pulling a prank on us. I'm gonna close Extreme Injector, open Extreme Injector again. Make sure it actually compiles because that's important. Oh, of course, we need CRT secure, no warnings. This is just this is a stupid C thing. You guys don't need to worry too much about what I'm doing right now. Okay, build. Just because I'm running a newer version of C and they don't let you, or have C++, and they don't let you do certain unsafe practices. So you need to circumvent that. Okay, CS:GO, we're in here, and we want to inject our Bhop now. This is injected. Boom. Okay, now we want to go into our game. And Bhop. Boom, boom, boom. Okay, we're good now. Yeah, so you can see what we're doing here is when I hold down my jump, it jumps every time I hit the ground. So I'm not really good at this. Like people who play the game, they have a technique for it. But basically, if you strafe side to side, you can go super fast, and it's a big telltale sign that someone's cheating in this game. But we're not here about the game; we're here about the cheat. So, anyways, this works. So, and I set the cheat up actually. I don't know if I really set it as I was doing it, but I set the cheat up so that when I press the insert key, it deloads the cheat. You guys can kind of see this is basic code here. So, I mean, it's not too much to wrap your head around. This part here just opens a console, and attaches your standard input output to the console. You can Google that if you're not totally sure. Yeah, so we've done the Bhop. My next thing that I want to show you guys is how to make an ESP. Now, this is a little bit more challenging, albeit it was the first cheat I ever made for this game. So before Bhop. Sorry, I'm just looking for paint. Yeah, so if we are looking for what we need for the ESP, the way that glow quote unquote works in CS:GO is every player can have an outline drawn around them so that you can see them through walls and whatnot. So I can show you guys what it kind of looks like for an example of what we're expecting. I've just injected it here, and so now you can see how you can see all of these players through the walls. This is built in. It's for the spectator mode in the game, and it's just abused by people doing malicious things. You can see how they kind of disappear, which is notable in this. It's because in order to thwart cheaters' efforts, the server doesn't send you information of the coordinates of enemy players or of any players actually. Yeah, no, of enemy players only. Sorry, of enemy players when they're so far away that you wouldn't be able to see them. So again, the idea is that way you can't see where people are across the map in this game. There's strategy involved with seeing where people are going and stuff, so that kind of stops that. So there's a certain flag on every player, a boolean that's true or false if they're going to be rendered or not. It's called dormant, and it's simply just an offset away from the entity object. And yeah, you just check if it's true, then they're not being rendered. If it's false, then they're being rendered. And for the glow, every entity in the game has a glow index. So there's a global array of glow information, and that exists at a certain memory address. So this array, I'm going to start drawing this for you guys. So somewhere in the memory, geez, this brush is small. I have no idea how to make it bigger. I'll just zoom in. Okay, so somewhere in the memory, so this is our memory again, going 0 and up, or say this is a module base address is the best way to look at it, and up. So somewhere in the memory, there's an array called the glow object. Coders have dubbed it as, and this. So these are just different elements in the array. These give the information whether we're drawing the glow for certain entities that exist in the game. So sorry, consider this also part of the memory here. So we also have an entity list, and this is also an array, and this includes all the entities. So basically, we're going to find all of the enemy, all of the entities in the entity list here, and so this is a pointer, and it points to some other memory location. So when we find, and then so we're going to get an entity object here. So the entity, and this includes your glow index. So this includes the index in this glow obj glow object array for the glow for that entity. So basically, there's two steps, and first is to loop through the entities, and second is during every iteration of this loop, we need to go and find the glow index of that entity, and we need to go and inside of this glow object, there's red, blue, green properties that set the red, blue, and green color of the glow, and we set these to whatever we want, and this causes the glow to render for their corresponding entities with that glow index. Pretty simple. So why don't we give her a go? I think we're just gonna go to 8:30 here as I originally planned. It should cover enough for getting the glow done, and then I have code for an aimbot, and that will be in the GitHub. So if you guys want to look at that, then you can feel free to. Um, yeah, so we're gonna make another module here. I kind of contained the Bhop module on its own. So this Bhop runs every iteration of our main loop. And so we're going to also run the glow because it's a continuous thing. We need to just constantly be updating those values for the glow. As I kind of mentioned earlier, if you envision this as time, like this is time going on, and every one of these are let's make ticks. Every one of these ticks is when the game gets rendered. So every time before this gets rendered, at some point we need to set the information for the glow. Um, except we're not doing any hooking, so we can't do this to a science. Like if we could hook this function and run the glow every time right before, that would be amazing. And there are ways to do that, but it's totally out of the scope. Um, if you guys are interested in that, it's called vtable hooking. You can find that online, whatever. But again, for now, all we're gonna do is we're just gonna run a continuous loop similar to the bhop that just keeps running, and hopefully we hope that one of these points where it runs is gonna be before every render. Sometimes they won't be, and you can see a little flicker, but in general, it's like pretty much 100%. Because it runs so damn fast. Now, that being said, in external cheats, if you were to do this exact same technique in an external cheat, you might run into speed issues. Yeah, so that's why it needs to be in a loop. Because you would think, yeah, why can't I just set glow to true and call it a day? But this is something that the game resets, I guess, before every render, for whatever reason internally. So yeah, we're gonna call glow. We're gonna make a new function called glow, and this beauty is going to it's not going to check for any key state like the bhop did. It's just going to go and it's going to render no matter what. Obviously you could, if you want to get complex, you can make menus to do your cheats, you can make toggles and stuff, but again, this is just more expressing a concept rather than making a real world cheat. Yeah, so what we're gonna want to do is we're gonna want to find the glow objects address, like I mentioned. That's our array there. We're gonna find the local player because we need that in order to know our team. Our team is just an offset from the local player as well, just like the flags was in the last example. And then we need to find the entity list, like I had talked about as well. So So our glow object, like our glow array, it's an array of structs that are of this form. I'll show you guys. So somebody's reverse engineered the game and determined that this is what the glow struct looks like. So you can see our red, green, blue, and all sorts of other options that change how the glow looks. You can make it, like cover the entire player, whatever. So this is what it looks like, and so that's going to be the type of our array. So we can just import this in here um, for our convenience. And so now we know our glow object is going to be an array of type glow underscore t. So we can see here glow t, and this is going to be an array, so it's going to be a pointer. And this is going to be p glow object. And so we know that the pointer to this array exists. The pointer to this array exists at a point that we have an offset for away from the client DLL. So I'm just going to store the client DLL base address at the start here for convenience sake. So uint ptr t, and we have this in the early one, p client here. Yeah, and we'll store that in p client. So that's our starting base address. And so we take client, and then we add haze dumper signatures, typos, can't spell. Yeah, so that's going to be our address, and then our array exists at a point that is at the address that this address points to. So we're going to have to dereference that address here to get the address of the start of the array, if that made any sense. So when we dereference this guy, so this would be a pointer to a glow pointer, because it's a pointer to an array. Basically, we dereference it once. That's the bottom line. And our type is accordingly. And so this is going to mark, this pointer here marks the start of our array. And then we're going to find our entity list as well. So this will be uint pointer t. We don't have a type for the entity list, so that's kind of why we're not using it like it's the same sort of purpose. It's an array like the glow t, but we don't have like a glow t for entities, so we're just gonna use the pointer. The entity list, and this will be exact same thing. So we know where the pointer to the entity list exists. Or sorry, no. The entity list simply just exists at this address. So p client plus A's dumper digs entity list. And this is where, so now we've found the array for entity list. And that's where that exists. And we want the local player as well, because we want to know what our team is. I'll copy that from the last one for the sake of time. And the team is an integer that's an offset from local player. So the exact same thing as flags, like I said. So local team is going to be here. That's an offset from local player object. So that's our team. And we're going to loop. So the maximum number of entities ever in the entity list is 64. That's why we're looping through 64. So if we're going to loop into I equals 0, I less than 64, I plus plus. And this loops through all the entities. Boom. And so now what we're going to do is for every entity, we're going to dereference it because this is an array of pointers to entities. So in order to get the entity in the current iteration, we're going to have to take this this pointer for the entity list, and then we're going to have to add whatever offset from the entity lists based on the value of I that the pointer to this entity exists at. So how would we find that in practice? We would go uint pointer t p entity, and this is going to equal, so we're going to have to dereference. So p entity list plus the size of each entity is 0 times 10 bytes. That's why we're doing this. So plus 0 times 10 times I. So basically the number of entities before it times 0 times 10. So I'm hoping you guys are kind of getting what I'm putting down here, because my paint's nowhere to be found. Okay, here we are. Yeah, so entity list. I said this was our entity list, I think. So if each of these is 0 times 10 big, so like to get the address at the start of the first entity, it's just going to be plus 0. For the second entity, it's going to be plus 0 times 10. Third is going to be plus 0 times 20. You get the picture. So that's what we're doing. And this is a pointer. These are all pointers. Oh, I already showed this. So these are all pointers to some entity objects. So we have to dereference the value that exists here. Boom. So we have to dereference this value. We'll have to do a cast. Pointer of a pointer. And that's going to be the starting address of our entity object. Next step will be to get the team number of this entity to see whether it's a friendly or an enemy. But before that, we're going to have to see if this is a valid pointer. That's actually more important, because if we try and dereference a null pointer, it's going to crash the entire program. So we're trying to see if this value in the array actually exists at all. So basically, we're just checking if this is null. So if p entity is null, then we're going to continue. So we're going to just skip this iteration of the loop. And now we have to get the team number. So int team or enemy or entity team, let's say, because it's not for sure an enemy, it might be a friendly, is equal to dereferencing an integer again. There's just an integer located some offset away from entity, the entity object, and it's the same. It's all entities are the same. Local player is just another entity. So everything you can do with local player is the same with any other entity in the game. Team. And so first thing we're going to check is actually we don't need to check anything about the team because we're drawing glow for both teams, green for ours, red for the other. Now we're going to have to find the glow index, and that's also an integer. And we talked about that, but I'll show the picture again in a sec. And so this is another offset glow index, boom, pow. And so now we need to find the corresponding glow object, or rather the pointer of the corresponding glow object. So glow t pointer g, or pg. I don't know what a nice way to do it is, so I'm just going to go g. Is equal to, so glow p glow object, the start of the array. But we want the element at the index, so glow index, and we want the pointer to this, so it's going to be the address of this. Actually, you could have just added this would have been the same thing as saying p glow object plus size of glow t times glow index. This does it clean for us. And now we have to check the dormant thing I said, the stupid little thing they added to prevent hackers. So this will be done in the same fashion as integers are. It's just another property of the entity, and we're checking the dormant netvar. I thought maybe it's a signature. Yeah. And it's a Boolean. Sorry, I didn't see the message. Yeah, the recording for future reference. It's going to be on YouTube for one, and secondly, I'm gonna link it up in the Discord. I'll just send you the YouTube link. Okay. And so yeah, we've gotten dormant is dormant. So if it's dormant, we don't want to render it. So we'll continue, skip this iteration. If it's not dormant, we should be good to render. So we just got to modify this glow object here. I'm going to be clean because we don't want to waste time. Technically, the most efficient thing would be to check before anything else if it's dormant, then exit. And now, after we've cleared all of our conditions, we want to take the team, take the glow index, find the glow object, boom, boom, boom. So if this is our... and there's actually one more condition. So for the teams... in CS:GO, I think like team 0 is terrorist and team 1 is counter terrorist, or vice versa, whatever. and team 2 is spectator, so we don't want to render any spectators. I think it would still work if you didn't do this, but it's just good measure. So if entity team is greater than or equal to 2, then greater than or equal, not equal to greater than. Then we want to continue as well. And that would officially clear all of our conditions. So now we're going to do if entity team equals local team. Boom. This is a friendly. Otherwise, this is enemy. And now we just got to set the properties of the glow object that we want. For the sake of time, I'm just going to copy and paste because it's really simple. So yeah, so you can see the properties we're setting. So we're setting red, green, blue, alpha. I like to set the alpha to 1 would be fully opaque, 0 would be transparent. I like to set the alpha to in between because it looks kind of nice, but that's just me. And so yeah, so friends are going to be green, enemies are going to be red, and render when occluded is the flag that actually tells our glow to render. If we just said render when occluded and didn't set the color, it would default to white. White with 100% opacity. So I think we've finished our glow now. With any luck, which I didn't seem to have last time, but we might have it now. With any luck, I should be able to just build this up. Go to CSGO. Oh, I have another cheat running right now. My bad. Okay. Yeah, so now nothing's happening, and I'm gonna go and I've built it. I'm gonna go inject it now. Pray to God, and wrong one. Injected. Hasn't crashed yet. That's a good sign. We also don't have glow though. Might have done something stupid wrong. Oh, it might have just built the wrong project. That's totally plausible. So we set the red, green, blue. Hmm. It's really not liking me today, hey? I'm just quickly troubleshooting where I screwed up. Oh, we're currently still injected. Sorry, I'll tell you guys in 2 seconds where I made my mistake. Okay, so I've just isolated that our mistake is not inject. Oh, it's working. Okay, yeah, so I just isolated that our mistake was in this section. I'm probably just doing a continue where I shouldn't. That's my guess. Oh, index. Dormant gets dereference correct. Anyways, man. Oh, entity team less than 2. Oh, I made a mistake. Sorry, I got my I figured it out. Sorry, guys. I got my team numbers wrong. Actually, teams of number 1 is spectators, and number 2 and number 3 are the terrorist counter terrorists. And again, it's amazing. You can spend so much time on bugs like that. Like if I hadn't, I spent like the last 2 days making this workshop, and if I hadn't looked at that, had that ready, I would have been screwed. If we inject it now, it should work just fine. Yeah. Okay. So this is the code we just made right now. We have made a Bhop and a wall hack. Aimbot is a little bit out of the scope. Yeah, I'm just going to show you guys that the Bhop works, and then I'm going to wrap up the workshop here. See if I can get a few good ones. Yeah, boom. Okay, and sorry about the phone again. Yeah, so sorry I couldn't get to aimbot. I think the math would have been really tough to cover anyways. I have put it on GitHub, like I said. I'll send that right now for anybody who is interested. Sorry, I'm just getting a GitHub, and I'll send it in chat. I'll also put it in the Discord, I think. But you guys are here now. Yeah, there's the link for the GitHub. I don't think I've pushed my current changes though, so I'll push that in a minute here after the workshop ends. I'm just going to check if I had anything else in the slides. Yeah, so I had some resources here for anybody who's interested in looking into this topic any farther, especially if you want to do other games and stuff. There's tons of resources. It helps a lot. I recommend everyone to check it out. Guided hacking, by far the best. It's oriented around people actually coding cheats rather than just using them. Unknown cheats is really good. Lots of coders there. MPGH is just a lot of people downloading. Yeah, I can share the slides as well. Yeah, yeah, I'll make sure to do that. MPGH is a lot of people, just kids and stuff, downloading cheats. It's not as developer oriented. I found this Reddit. I've never really used it. It looks pretty small. That's why I gave it a bad rating. Feel free to ask me questions on Discord. I love answering this sort of stuff. I think it's a really fun concept. It's totally out of the ordinary from typical programming stuff. So it's always a fun refresher. I think that covers everything. Yeah, so I'm really happy everyone could attend who did. Like I said, this will all be recorded. Our next workshop will be in November. That'll be posted closer to then. That'll be a which workshop was that? That's going to be it was Kushal. Yeah, it was going to be our React workshop. Our Go workshop was postponed, and I did that kind of in lieu of the Go workshop right now. And the Go workshop will be postponed to a later date. Thanks, guys, for coming. I'm going to end I'll share the slides first, and then I'll end the meeting here. Anyone with the link? No problem. Hope you guys enjoyed.